Okay, good morning. Welcome to
FamilyMath960.
Sorry about that. Today we're going to take a break from our probability projects, and we're going to do a really, we're going to explore an unsolved problem in math. That's kind of a surprise, and I just learned about it yesterday. So it says this: any number of the form 3 plus 8n for some positive integer n is the sum of a square and double a prime number. So in other words, 3 plus a at n equals a squared plus 2p. This is still today just a conjecture, neither proven nor disproven. Okay, so what do you think about that?
It seems like really hard to actually prove. I mean, it's sort of like a random conjecture.
Okay. Yeah, that's an interesting observation. Any other thoughts about it?
It's pretty general. Like, it just says you have it's some square and some prime that are less than the number you have.
Yeah.
It's not really like a way to find which two numbers there are. You just kind of have to look.
Yeah, that's probably what makes this so difficult to prove, is that for any individual number you're looking at, you can probably find a solution. But finding sort of a procedure to find that solution is hard. The thing that surprised me about this is it's such a simple statement. 8n plus 3 is a square plus twice a prime. And yet, I think in this section of this paper I was reading, I think this was went back to Euler, or maybe back to Fermat, I can't remember. But it's a couple hundred years people have been trying to solve this problem. So, how would you like to start in exploring this problem?
Well, we could just look at some values of n and just try to find them.
Okay, cool. All right, so where would you like to start?
Well, we need to start at like 1, I guess. So, the first.
It says n has to be positive.
Yeah.
Yeah, so n would be 1.
3 plus 8n. So
That'd be 11.
11. Okay. Is this a square plus twice a prime?
Oh, let's see. Well, you could do 1 squared plus twice 5.
Okay. Anything else?
Let's see, 2 squared. No, because it's not going to be twice anything.
3
3 squared also doesn't work.
Because 1 isn't prime.
So that's the only one.
Yeah, 1's not prime. And with 2 squared we'd get 4, and then we'd have to make it plus 7, but that doesn't work for twice a prime. Okay, cool. What's the next one?
So n is 2, so
Sorry, this was 1 squared plus 2 times 5.
So it's 16 plus 3, 19.
19.
That's the next one.
Okay.
We can do, let's see, 1 squared doesn't work.
We could do 3 squared plus 2 times 5.
Okay.
Let's see, yeah, that's the only one that's gonna work. Because you can only have odd squares and odd primes, or...
And these numbers are always going to be odd.
Okay.
It's like,
All right, so that's the first observation. So the squares have to be odd, and the primes have to be odd.
These don't necessarily. You could have a 2 here, maybe, at some point. Because this term is always going to be even.
Okay, so that's interesting. So maybe we don't have to have the primes odd. Not sure. Okay, but maybe we can explore that as well. Why do the squares have to be odd? Can you tell me?
Well, squares have to be odd because no matter what, this part here is going to be an even number.
Uh-huh.
And you have to get an odd number over here, so you have to do even plus an odd. So squares have to be odd because it's the only way you can get the odd number.
Okay, nice. All right, squares odd, primes odd, maybe. Okay, let's do the next one just for fun.
So it'd be 27.
5 squared, no, because that's gonna lift 1.
3 squared.
3 squared, no.
1 squared. Yeah, that works because 1 squared plus 2 times 13.
Okay. What the heck? Let's do one more.
That's 35.
It's 1 squared plus 2 times 17.
All right, does it have any other solutions?
3 squared would go.
5 squared plus 5 squared plus 2 times 5.
Okay.
So this one was 2.
And 3 squared didn't work because 35 minus 9.
26.
That also works.
That also works, it looks like.
Okay.
So
All
it looks
right.
like each one doesn't necessarily have just one solution.
Okay. 3 squared plus 2 times 13. Okay. So although, we still see a couple of interesting things here. All right, so let's go and look and see if we can explore a little bit more and see if we can see anything we can see about the primes.
Okay.
Okay.